I recently got a long-awaited upgrade of my hi-fi and home cinema space. That's why I've decided to also upgrade the look of my speakers. I've been quite happy with my DIY Dolby Atmos kit of 7 identical coaxial speakers plus 2 subwoofers, but they didn't look very nice. I have recorded 2 different videos. One shows the veneering of the 7 small speakers. Another video shows building new subwoofer cabinets and veneering them. This video is about the 2 subwoofers. This is one of the old subs. It's a Peerless XLS10 in a sealed box with miniDSP running Linkwitz-transform. I used sealed box because I wanted to use it for music as well, but it never worked really well. Now I'm just gonna do a ported box for a maximum output for movie use. I used WinISD to simulate a subwoofer box. It's an old software, but that's something I had installed and I've used in the past for simple projects like this. I'm not going into details of subwoofer simulation or design, and I'm not even an expert in this, but here I have the vented box, 28 liters, 28 Hz tuning frequency. It gave me some sort of compromise in how low, how loud I can go. And this response is a bit odd now. We have this step here, so I add a filter here to basically even it. I have a separate DSP box for my subwoofer filter, so I can add these things if I want to. Another thing we kind of want to look at is cone excursion. Now, for example, we see here's the tuning frequency, and after that, in a vented box, the driver excursion just gets out of control. You usually want to use a high pass filter or so-called subsonic filter for these things. So, for example, here, if I use 15 Hz filter, it just limits the excursion within the limit, which is here 12.5 millimeters. It has quite minimal impact on the response. And this cone excursion was with 200 watts, which is approximately what I have available, which is not a huge amount for subwoofers, but I have a small room, 2 subwoofers, so this will be enough. I've been driving them in a sealed box before, and now it's gonna be vented, so I'll get more out of them. So this will be plenty. And this is the port. So I have one port, rectangular shape. The cabinet is 15 centimeters deep inside. So if I use a port that's 4.6 centimeters wide, it should be around 87 centimeters long, which is what I get there now. Port air velocity is one thing. You kind of need to check that it's low enough that you don't hear any noise from the port. Depends on a bit of a source. Some say, I think it's like around 17 or 20 meters per second. Some say it could go to 40 or something. So if you don't know what you're doing, you would probably want to check at the delays and stuff like that as well. But this is just going to be a simple cinema subwoofer. I would not trust my skills to make a music subwoofer, and that's what I wanted to use the sealed versions of this before, but it didn't really work so well, so this is just going to be for cinema use. I designed the cabinet with Sabre 3D free version, so this is how it looks like. It's a slim cabinet because I wanted it to go nicely next to the wall, and the port is integrated, so that's why there's the port opening here, and the legs are kind of included in the side panels. So this is 53 centimeters tall, 63 centimeters wide, and 19 centimeters deep. And if we take the panel away, so you can see how it looks like inside. So the port is integrated here, does a 90-degree angle, and there's just one support bracket here, and so it's this area here, the main chamber, which has a volume of around 28 liters, and the port cross-sectional area is what is simulated, and the length is kind of the main length of this port. But now the thing is that this is the unknown, how it behaves when the port, first of all the mouth here and also the opening inside the cabinet, because it's kind of like, if you think of the port opening here, you would say, okay, it ends here, but actually 3 of the walls continue, only 1 of them stops here. So effectively the port is probably going to be longer, and maybe same here a little bit as well. I'm in the garage now. I have plywood for 2 subwoofers. It is 18mm hardwood plywood, 25mm front baffles. I don't know anything about plywood really. I don't think it's the highest quality one. At least there is no cavities inside like in some other plywood I've had, but it kind of feels like that the front peels off a bit, so I will probably use screws as well, not just glue. This is roughly how it will look inside, so the port will be integrated in the cabinet structure. This is how I'm gonna build it first, to glue all these parts visible here now. So this is the front baffle, and when these are all glued, I'm gonna veneer the front, put a driver in, and just screw the rear panel in, and then I can do some measurements to see that the tuning frequency is what I expect it to be. And yeah, you can see somewhere here it's not like a premium quality plywood, but it's gonna be good enough for this. It's gonna be quite solid structure. The subwoofer building is progressing. I use a combination of clamps, but as I only have 2 of the long clamps, I also use screws and some weights as well, and just basically build 2-3 sides at a time, then let it dry, and then continue next day. And whenever you do use screws, just do the countersink so that you can leave the screws there, and then just fill the hole. The downside of plywood is that even this thick one, it's not completely straight, it's a little bit curved, or maybe just because it's not very high quality plywood. If you buy MDF, it's always straight, but it's just a bit nastier to work with. Now I have all the internal pieces glued together. So here is the integrated port, and it's not exactly the same measurements as I simulated, and I also don't know exactly how this 90-degree corner here and the end of the port will change the tuning frequency. So the next, I will just screw the rear panel in, I will put the driver in and do some measurements to see what is the real tuning frequency. Now I need to finish the front of the cabinet so that I can put a veneer and cut a hole for the driver. First I need to fill the screw holes and sand the edges and the filler. The cabinet is still missing the rear panel, but I'm now preparing the front with a shellac based primer sealer. It's white because it's the only one I found. I ran out of my clear one. Now the sealer is applied. I'm just gonna give it a quick sand at 120, mostly to get rid of the dried blobs of the sealer here on the edges. Next I will cut the veneer. This is 60 by 200 centimeter walnut veneer. It's fairly thin, and then you have this paper packed adhesive layer here in the back, so it's the so-called peel and stick. If you do plan to use veneer in your speaker project or any other kind of project, it's good to check first what size of veneer is available, because ideally you want to be able to just use one piece without needing to attach 2 pieces together. This veneer is easy to cut with a utility knife. Okay, now I just need to plan how to put this veneer. This is a lot bigger piece than what I used in the previous project, so this is the second time I'm actually now doing veneering. So just need to be a bit more careful when applying it, not to leave any huge air bubbles inside. So I start by peeling it somewhere in the not maybe midway, but some distance. Then maybe just put something here that it doesn't get stuck completely if it accidentally touches there. Then I kind of want to make sure that we have enough spare ones here on the edges. Maybe I'll just put some weight here a little bit. I think I'm quite happy with it now. Then just start getting the glue in somewhere there. Then start applying some pressure. We don't really push it properly yet, but like decent pressure to get it in place. Avoiding air bubbles. So I'll just take the weight off and then we just start peeling it more and keep applying light pressure, avoiding air bubbles. Gonna need to be a little bit careful with that because it is a thin layer of wood, so especially across the crane, the veneer just breaks easily. Alright, I'll just cut now some here of the excess away that I know I see a little bit better where is it going. I would not have needed to include these legs, of course, in the main one-piece veneer, but as they fit, I just want to make it like this. So you see it like this, it breaks easily, the veneer, but when you go along the crane, be careful. And now we need to start applying a lot of pressure to strengthen the glue bond. So they say that any kind of roller is not good enough. If you use any roller, at least needs to be small. I use veneer scraper. I think it's just like any scraper. It basically has a blunt blade, so you can apply pressure on a very small area. It's a bit scary to use this because it's basically like a blade, but now this is a bit tricky if I use this with two hands because this is moving, so I will turn it a little bit. I will start applying the pressure from the center. Kind of trying to hold it here with my leg. Just need to be careful with the edges because this will break them otherwise. This scraper tool was recommended by the seller and manufacturer of the veneer. And when I'm done, I will leave it for a couple hours before I start trimming the veneer edges. I think this is basically push as hard as you can. Then I need to trim the edges of the veneer. The manufacturer says to use utility knife, and in my previous speaker project I tried utility knife and router and eventually preferred the router results, so that's what I'm gonna use now. It's a big router to operate with two hands, so not as nice as a trim router would be. With router you just go along the edges of the veneer, and the bit used, it has a bearing here, so it will just follow the edge of the cabinet. The adhesive also caused a little bit of a mess in the router, so yeah, also the bit gets stuck, the glue gets stuck here, so I just clean it every now and then with some alcohol. Let's look at the edges. You can see that
the router has taken some of the primer away from here. I guess it was a little bit higher, this, and then yeah, we do have some of the adhesive here, but it gets off easily. This edge needs to be sanded also, because you get this kind of fluffy edge. And here was one thing that when you may think of, oh, this kind of small holes in the plywood doesn't really matter, the veneer will cover it. But if the router bit follows this, it just bites a little bit too much. Luckily it's not bad here, but you can see that it took a little bit of extra here. I'm just gonna tidy the edges a little bit.
The next job is to mount my Peerless XLS10 driver. I'm gonna place it in the middle of the front baffle, and I'm gonna do flush mounting. Flush mounting is not necessary for subwoofers because you don't get diffraction, but it just looks a lot neater. I'm using my router for the flush mount and the hole. I've changed the bit now, I don't know what it's called, but it cuts at the bottom and the side of the bit. And I'm using this guide rail to do a circular cut. I made a 4mm hole in the middle now. Then I need to just mark the radius. I need to do a small test cut on this because you don't want to cut too much. The router guide rail center pin comes where the hole is and will rotate around the center pin. When you do all this, it's good to clean the plate of your router, that you don't smudge too much stuff on the veneer, but overall you will get some small marks here, but then at the end we will sand it anyway. Let's do a small extra step here now. I'll just kind of knock or scratch the surface a little bit with the blade. I haven't done any stupid mistake with the measurements. I think I'm still a millimeter or two off. Another thing you may want to do is to check the depth of the cutting. So this is the same plywood I've here, so I'll see how it cuts. I've now set the depth at approximately 5mm, but it's difficult to set it accurately. So I will just do a test cut and then I will adjust if needed. That's pretty much exactly 5mm. We want a little bit less, so this one does have like a fine tuning. I think that should make it. I always find the depth fine adjustment a bit fiddly, but after a couple more test holes I got there. And now starts the scariest part. It's the most visible part of the speaker and it's difficult to hide your mistakes. I made small marks on opposite side of the diameter. Happy with that, so now just go around the full circle. And that's the first round done. I need to go another one on the inner edge to make it wide enough, but as you saw, it's quite time consuming to get all the adjustments right, so I will do this circle on the other subwoofer cabinet first before changing any of the router settings. Now I have the flush mount done, no issues here, just tidying the corners, the edges. Now I need to make the hole, and there are two options here. I could use the router just to go the same way as this. It's 25mm plywood, so it takes a few rounds to go through it. It makes a lot cleaner hole than the other option, which is jigsaw, so you just drill a hole and go around with the jigsaw. I've got so much work with my 7+2 speaker multi-channels project that I think I'm gonna choose the jigsaw here. I'm also not too fond of the smell of burnt plywood. I made a few holes here to start the jigsaw cutting, so I'm just gonna follow this edge here. I'm just gonna do it outside because my vacuum doesn't fit in this one, so I'm not gonna film it, but it's just gonna be a simple jigsaw cutting. Now I got holes. I'm happy I took the shortcut with jigsaw instead of going 4 or 5 rounds with the router, because as you can see it's thick. So now I'm just gonna clean the edges, tidy them carefully, try not to break the veneer. I have now tidied the edges, it looks good, and now it's the moment of truth. This is where you see the results of spending some time to get the router adjustments correct. I will use this sealant tape for sealing between the cabinet and the driver frame, and if I don't find any nice looking wood screws, I will use these, I don't know what they're called, the nuts you put on the back side, so then you're going to use just the nice machine screws. I'm trying to do some recordings here now on the garage floor, so I have my unique microphone very close to the driver, and then I have a power amplifier here which is connected to my laptop running Rev, so just a headphone output, the power amplifier, speaker, microphone, back to the laptop. Then do a sweep. And we're gonna be looking at the results shortly. And these near field measurements, you need to measure the port separately. So then we do another sweep with the microphone just at the reflex port. These are the results from the garage near field measurements. As you see, there's quite a lot of them because I just couldn't understand exactly what's going on. This was the typical shape from the driver and this from the port. So from the port we could kind of see that, okay, the peak is around 30 Hz, kind of expected, 28 Hz tuning frequency. This stuff here, it's probably some port resonances. We would cut around 100 Hz anyway, so these are not a problem. But this driver response I really don't understand. Again, I don't know what's this. Doesn't matter necessarily too much over 100 Hz. But I don't understand the shape of this. Also, we should see a dip where the tuning frequencies, and now we're gonna have almost like a local peak. I tried moving the subwoofer a bit upright, different levels, different things. It didn't really kind of change the theme here, the trend. This was one where I tried to combine the driver and port, and it also doesn't make any sense. Because of these results, I then thought that, okay, I will try to take the subwoofer outside where there's a little bit more space around than in the garage and see if it makes any difference. The measurement results in the garage were not as expected, and although it should be okay to do near field measurements in a small space, I wanted to take the cabinet outside and just have a little bit more space around and repeat the measurements. And this is the driver measurement outside. It's a lot cleaner now, don't have these odd things here or here. That made a big difference. But okay, now we have the dip, which usually tells us the tuning frequency, but that's like 22 Hz instead of 28 we were expecting. And the port response looks a lot cleaner now as well. There are less resonances. This has also moved, and again that's around 22 Hz instead of 28. All our measurements now kind of indicate that our tuning frequency is around 22 Hz. Here I have the VituixCAD now. It's a funny name for a Finn. This is an extensive tool and it's the first time I'm using it, so I cannot use this. It's complicated. You can do a lot of things. It's very impressive. For this one, I'm just gonna use the cabinet design, which is just one of the many tools inside this software. The similar box parameters here give a little bit different kind of results. Probably simulation works a little bit different way. There's a lot more parameters you can input here. So we have this kind of bump here, and so it kind of indicate maybe kind of a little bit lower tuning on this one as well. I don't know. This was more like just a sanity check that the WinISD wouldn't give me complete nonsense results. It's different, but that doesn't explain all the huge differences I see in the measurement of my cabinet. I think the conclusion is here just that the effective port length is very different from the calculated one. After all the analyzing and thinking, I decided to move forward with the cabinet build as planned, and I only added one extra support inside and then just glued everything together. Now I have both subwoofer cabinets finished. The rear panel has been glued. All the screw holes have been filled, sanded, coated it with shellac based primer sealer. Now it's just veneering the rest of it. I have all the veneer here cut for the two subwoofer cabinets. I'm going to start from the bottom. Of course, I wouldn't necessarily need to even put veneer here. It's also a bit awkward to put it here and difficult to trim, but I will put something even if it's not going to be super tidy. Now the thing that I've put the front baffle veneer first, of course now then everything else that comes after it, you kind of get the edge visible from the front. Normally you would put maybe the bottom first, back, sides, front, top, so that kind of the edges are hidden in most of the cases. But in this case it was more important to get the hole nicely cut, which is a lot easier when you veneer it first, and it's thin veneer, thin glue, so yeah, the edges won't be that visible there. And you will see the subwoofer from kind of above anyway, so the top is the most important one, which I will put the last. When using the router to trim the veneer, we have this white line here at the edge, which the white is the adhesive of this veneer here. When you sand it, it kind of gets, most of it gets off, but you still get a little bit of it visible. So there's an extra step I'm doing just to trim some of the adhesive off as well. And the smudges we have here, that's actually when I trim it, the veneer and the adhesive gets around the trimmer bit, and it gets some of the glue residuals here as well. But that will get off when I sand it. But so I'm just taking a sharp knife and just kind of carefully go here to cut the adhesive layer under the veneer, and then when you just kind of go carefully not to cut too much of the veneer. This is what I would say now it's the downside of this PSA veneer. I mean, I've never used anything else, but I'm assuming that you don't get this in the if you use some other glue, because the glue gets at least hard at this point. Then we will just check it once more after sanding it. I'm placing the veneer piece the same way as did the front baffle, so they're first cut like 5 to 10 millimeters over the edges, and then I peel it a little bit, attach it somewhere, make sure that it's centered, and then start going with the scraper to apply pressure. Then I'm going to trim the edge with the router that follows the edge of the cabinet, cuts the excess veneer away. Now both subwoofers are fully veneered, so the next one is sanding, And the sanding will hopefully get the edges a bit nicer and get some of the scuffs, and especially in the front baffle there's quite some scuffs from the router, some of them even a little bit deeper, so I hope I can get them all off. This is how the bottom looks like, so we wouldn't necessarily need to have this one, it's not really visible. These ones need to be here because the sides are visible. I didn't do anything about the board because it doesn't matter. Of course, like painting this inside or something would make it look nicer, but here we also see there's a lot of the adhesive. Done the sanding and I think I got all the router marks off. There's just one note on this. Some part of the veneer had, especially in some light, kind of lighter patches here. I'm not sure what it is. I hope it goes away when I do the finish, but that's also why this bit is on the back side of the box. There is still a small white adhesive line here. At least when I was doing the smaller speakers it was less visible after I put the oil. Also a small reminder, you need to be careful with sander. Cut off a bit too much here. To finish the cabinets I'm using the same Osmo Polix oil I used for the small speakers. I have this kind of coarse, I don't know what its material is, but you can use any kind of foam thing or brush or something, just to first apply it, and then I have cotton cloths, or I use old clothes if I have, just to properly then apply it. This is where you really see the kind of the wood grains become visible when you start applying some oil. And of course almost all the finishes they have this kind of wet look, so it comes darker, and if you have light wood it may become also a bit yellow with the wet look. So if you don't want that, Osmo also has an oil called Raw, and it has a little bit of white tint in it, so it basically retains the kind of untreated wood color. I've used it once for peach, I think, and when the oil is kind of everywhere then it just almost like wipe it off with the cloth. The point is not to keep it kind of wet, soaked wet. And then it has 8 to 10 hour drying time, and then you can do a second coat, and then it says it takes another 2 to 3 weeks to fully cure. It does smell for a while as well, especially if you take it inside. I've got the cabinets finished now. They've been in the garage for a couple days, and I got the cable inside. Binding posts are here in the bottom, and I'm gonna put a little bit of wool inside, just making sure to keep the port opening free from any wool. And then I'm gonna finish the thing by putting grill here. It's by decoration, but also a little bit of protection. This is the end result. I'm quite happy with it, especially in a dim room where you don't see the small flaws, but overall it looks really nice. Some of the veneer like used in this sub is a little bit lighter in tone than some of the other ones used in the small speakers. Sound-wise it works nicely in my small room. It goes lower and it's louder than the sealed box version. When I first started thinking about this design, I imagined quite a bit smaller box than it is now. Of course it wasn't a surprise anymore after designing it, but it still goes nicely next to the wall, doesn't take a lot of floor space. Here are some of the measurements in the room, which again is very different from actually measuring the subwoofer only in near field. So I wanted to put one of them behind the TV because there was just completely dead space. This is from that subwoofer, so we can see that there's quite nice flat here, kind of 20 to 40 Hz, but then a huge deep around 50. So normally I would find kind of nice place for both of them, but I wanted to have this one here, and then I started looking a place for the other subwoofer where it could complement this in a way that I would get fairly flat. this is where it ended up being. Again, it looks awful here. When they're both together, that's the sum. Overall trend is fairly flat. Yeah, it's still 5+ dp changes here, but that's the reality in a small room. A little bit bigger dip here, and it also depends on, like, this is just from different spots in the couch, so even there it changes quite a lot. But yeah, this was in the middle where I usually sit. And then of course my AVR, my Denon amplifier, it gets auto-C calibration, so it does its own tricks, and that's good enough for me. And these are without any of the miniDSP filters I simulated and planned to use. I had some problems connecting the miniDSP, and I just decided not to use it for now, and to be fair, maybe I won't even need it. Of course, the thing is that, like, if you want to protect, especially if you have a little bit more power, to put the high pass filter to protect the cone excursion at very low frequencies, but I don't think that's going to be an issue in my small room. Thank you for watching, and please check the other video on the small speaker build.